filling in the time to double. And then R is 11%, which would have come from 0.11. Number 24. Remember, there's not time to get all the work done. Did you use PERT? Maybe you use PERT. It doesn't have to look like this. Remember, PERT is okay for exponential growth and decay. It's what I showed you. The final answer, as far as the initial amount, was 0.41 grams. And I think for number 24, was that the only thing missing on 24? Yeah, just the initial was what was missing. So 0.41 grams. You could have had some more decimals. The 0.41 grams. Number 34. There's the answer still for the last one. Number 34, you had to plug in your 2 clues. Plugging in 1 hour, plugging in 10 hours, and saying, hey, one is double or 2 times the other. One is double or 2 times the other. And then you had a nice little equation to solve. Ending with b equals ln of 2 over 9. That was your missing coefficient. And once you know the missing coefficient, you can take the t and plug it in, 397 bacteria. Number 48 was actually a little crazy because they gave you a formula if you looked at the directions properly. Remember, it's not so much you have to memorize all this stuff to do with sound intensity of different sounds. They actually just tell you, hey, guess what? There's this thing called sound intensity, and I'm going to give you some extra information. But long story short, to figure out the intensity of a sound, all you have to do is plug in the intensity divided by the initial intensity. I forget what that sound was. What was the sound they were measuring it to? Do you guys remember? Was it the faintest whisper? They were comparing, though. Remember, they were comparing to... the faintest sound that can be heard by the human ear. They're comparing it to the faintest sound that can be heard by the human ear. So I sub naught, now we know that as we get older, or as you get older, your range gets a little bit harder to hear. But this is just as far as the loudness of like a set pitch. It's not about the pitches per se, it's about the actual sound itself. But yeah. So they're comparing it to I sub 0 in the formula can be plugged in every single time to be 10 to the power of negative 12. So if you guys look at this, every single one says divided by 10 to the negative 12 because that's what you're comparing it to every single time according to directions. All you had to do was plug in the decibels of the new sound, whatever it is. So it's a simple plug and chug. Plug it in, and solve with your calculator. Plug it in. It's how to use your calculator, how to plug into a formula and use your calculator. There was no rearranging, there was no solving. 52 was super similar. It was giving you a formula having to do with pH levels, I think, right? They gave you a formula of how to find pH levels, and you just have to plug it into a log. They're saying, guess what? Logs show up here. Guess what? Logs show up here with sound and with chemistry. Do you know what to do? Hopefully put the log button in your calculator. So hopefully those weren't hard. They might have been a little confusing if you didn't realize they were giving you a formula to plug into, just showing you, hey, a logarithm shows up. A logarithm shows up. Number 66 was having you guys look at graphs, I think, right? And hopefully our notes helped a little bit as far as letter A being a swoop that looked logarithmic. Letter B was that whole swooping up like an exponential and leveling. That's logistic. Exponential growth. Oh, but it wasn't growing. It was decreasing. It was actually exponential decay. Letter D might have been weird because guys, didn't it just look like a line? So just linear. So they gave you some old ones, like here's a linear one, here's a quadratic one. They gave you some old-fashioned ones. That one's exponential, that one's that bell curve, the Gaussian, but letter E was the weird one because it was a piecewise function. So you could have said, oh, it's for one piece a line and for one piece a quadratic, or you could say none because it's a mix of different ones. So logarithmic, logistic, exponential, linear, none, or a mix of quadratic. It's a piecewise, exponential, quadratic, Gaussian. But that was looking at this one, number 6, which said, hey, what shape? What shape? Log, exponential decay, linear, logistic. That one, oh, interesting. I might have also said that's a cubic. If I hadn't been paying attention, It is like a line and a quadratic, but I could see how you guys might have said cubic. That's not horrible. Exponential, quadratic, and then Gaussian. The bell curve. All right, let's see what questions you guys had on odds. Let's start there. Only odds for right now. You knew the answers. You could look on Calc Chat. Where are we stuck? Yeah. Okay. Yeah. Put all the pieces together, kind of? Right. But getting there. Yeah. Nice thing is, Jordan, and guys, I'm getting hints about the test like all day long. So you might want to get out a special pen or a highlighter for hints about the test that you can refer to. For instance, I'm going to say there's not a problem like this on the test. However, I am going to say there is a problem like the first table that we saw. Okay? And I'm going to kind of correspond the two or relate the two, Jordan, because there is a problem literally like the tables for the finance stuff. But wait, which finance equation were we using here? The nasty n times per year or per? Yeah. So if I were you, I would highlight per, and I would highlight these problems in your homework being like, hey, check out this table. Because literally there is going to be a problem from this table on the test. Just one. But it is going to be a long answer. And you know there are points there, right? Okay. So to remind everyone or to let you know, like I'm not going to be putting on different isotopes, but the same kind of idea, aren't those really similar tables as far as like you're using PERT for both? You have initial on both. You have rates. This one doesn't. You have time. So let's talk about this one in relationship to that one in preparation for the test. So first of all, did the name matter at all? Was 7, like, would that be helpful? You guys okay with 7? Would you rather go over that one since that's the table that's on the test? Okay. That's a good call. That's a good call. Because it's similar, right? It's super similar as far as what to do. It's just, well, the first thing I would have said, Jordan, is you get to totally ignore the name. The name has no bearing on the math for us. I know. You think, don't worry about the name. And then you have PERT. And the crazy thing is, what we did in our notes, how I labeled, I would have made A equals 1/2 P and plugged in T. That's the first thing I would have done. And that's what I'm going to do kind of over here also, in that I'm also going to use PERT because it's continuously compounded. This one's a little bit nicer because they give you the rate, but remember, we still have to do something special with the rate. What are we going to do with that 3.5%? 0.035. Good. Who's the initial in any problem? What variable? Yeah, you guys tracking with this? Be okay? Time to double. Well, hold on. Let's plug in what we know. So we know right now A is equal to 1,000 e to the 0.035 t. So which one would be the easiest one between these two? Can anybody tell which one's the easiest one to solve for right now as is? Yeah, to get A, I think, right? Because all we have to do is just plug in 10 to our calculator. So that one's nice for this blank, because this one just says, hey, plug in 10, please. And you're like, okay, no big deal. I know how to find an E on my calculator, so I'm going to plug in 10, no stress. So that would be an easy plug in and solve. I'm not going to solve it because I think you guys know how to use your calculator, but stop me if you're like, I didn't know how to do that in my calculator, and I'll help. But I think the trickier one is this one, time to double. Basically, there's two ways of doing it. I'll prepare you for the harder way and then show you the easier way. That's the one that you said. We could just say back at the beginning, for time to double, we can make A 2P. Because when it started, it's twice as much now. And then we can do our e to our 0.035 t. We're trying to solve for t. Now, we could plug in 1,000 and say, oh, hey, 1,000 became 2,000. We could do that. In the half-life, we could say p became 1/2 p. But either way, it doesn't really matter where it started. What matters is the ratio, because to double or to half, you're always going to have a ratio. The p actually, in a sense, kind of cancels out. The 1,000 and the 1,000, if you divide by 1,000, becomes 2. So really what you're just doing is needing to solve for t in that e to the power of, which necessitates or requires you using... How do I get to t? Well, but you have to know how to rearrange it, right? So you're going to take ln of both sides. And then you're going to go ahead and divide by 0.035. Now, it's very important the order I did this in. I'm just trying to save, I'm just trying to save time. But you would take ln first, get rid of that. Then you would divide by 0.035. And then you would have your final answer for t. Joe.
Why is the question on chapter 0 exactly?
Joe? If you want to work on the review, you are totally allowed to. However, we are focused on 3-5 questions right now, so I'm not going to answer questions on the review. I'm not going to answer questions on the review right now. Matthew? I don't think... Oh, say it one more time, Matthew. You're saying, why did I solve for a rate, or when would you solve for a rate? Oh, if it wasn't given? If they didn't give you this, they had to have given you one of those. Okay, so with the time to double, check it out. This would be unknown. This would be an R. You could do the 2p and the p. They would have given you a time, so that would have gone here. So ultimately, I know it's kind of hard because we have something else. Let me change the color real quick. What if that wasn't there? So R was unknown. Time to double was, I'm just going to do something silly like, this makes no sense, but that's okay, 20 years. Okay, let's take that off to the side. Time to double, I still use my 2p and my p. I don't know R, I do know t. So here's the cool thing, I don't need to know p. I'm guessing that, well actually, they might have given you that, so you could have actually plugged in like 1,000 and 2,000 like Jordan and I were talking. But you could also just divide. Here's the main point. Just solve for the other variable. I mean, we could take this and we could rearrange it and say, hey, this is to get A. We could rearrange it and say to get P, you can always do A over e to the RT. We could rearrange it and say A over P, ln of both sides. R is always going to equal 1 over T ln of A over P. Now, I'm doing a lot of math to do that. I'm dividing by P, taking ln of both sides, and dividing by T. Like, you could memorize rearrangements of the formula. But I think it's easier just to plug in and say, hey, he's missing. Okay, do the math and get there. Or, hey, he's missing. Okay. Rearrange, divide, take ln's, and get there. See, you could memorize what's going to happen every time. But I think it's a lot easier, Matthew, just to stick with PERT, to plug in what you know, and to get to what you don't know. So if you need to get to A, but you have everything else, just put it in your calculator. If you need to get to T, well, I have to get there, so I'm going to have to divide. I'm going to have to take ln of both sides. But I would just do it step by step instead of trying to memorize what's going to happen every time. It's up to you. So I showed how you can rearrange and memorize if you want. The only problem is this only works for exponential growth. Does that make sense? Exponential growth and decay. So yeah, if you want, you can rearrange. The only thing I didn't solve for was T. T is going to be very similar in that with T. We divide by P, take ln of both sides, and then times 1 over R. Sorry, I wrote it in the wrong order. The 1 over R should technically be there. 1 over ln of A over P. But yeah, you can take any algebraic equation and rearrange and memorize what's going to happen. Jordan? You could. I was trying to prepare you for if they hadn't given you the initial, but you totally could have just said, oh, hey, I have the 1,000. Sorry, it's blue now. E to the 0.035. And it doubles. Oh, hey, I'm smart. I know that's 2,000. But see what happens when you divide? You get the same place I did. So either way works. Yeah, that's fine. Mm-hmm. The only thing I want to prepare you for is what if they don't tell you how much money to begin with? You're not stuck. You can still show it, yeah. Same thing with half-life. If they give you like, oh, hey, it starts at 10 and it cut in half, you can say, oh, now it's 5. Or you can do p and half p. Jason, go ahead.
So the problems that you put on Google Classroom, you just copy and pasted the homework from 3.5 and put it on the chapter review.
Wait, so hold on. At the beginning of class, thank you for letting me know that. I appreciate it. But should that pause anyone from being able to work right now? What did I put on the screen? And what did I have you write down at the beginning of class? Oh, no, it's okay. It's okay. But Joe, you should have had these problems written down like I had you do at the beginning of class, right? Well, I don't usually let you have your phones out in class. But it is very wise of you to want to be doing your review and to be caught up, so thank you. Thank you for bringing it to my attention. I will fix it. However, why don't you guys take a quick picture of this if you didn't get it earlier, because now we're using class time up. But thank you for letting me know that, because it would be a bummer. Kids could get confused later, and you guys already did get confused. So it is my bad. However, we would have been fine if we had paid attention a little bit earlier. Okay. That was enough time to get a picture. Guys, any other odds we need to go over that you guys stuck on last night in homework? Okay, but some of you might be like, I got the odds because I kind of just copied and tried to think through it as I went. So evens. Let's go there. You just had to grade it and you had to mark some wrong, or you didn't even get all the way to the end. So evens that we're stuck on. Or if you find an odd. Are we sure? Thanks, Joe. What's up? Okay. Nice thing is, I said there's one of these on the test tomorrow, right? And Jordan and I, we just worked through, or all of us who were tracking along, we just worked through one that was easier, and so this one's a harder one. Same formula, PERT. Plugging in P right away. And Matthew, it's kind of like your question in that they gave us a weird piece of information. So A is equal to 500. Sad thing is we don't know R. T's okay, we actually kind of never know him. Oh wait, we do know T for this clue. This clue says years, that's T, and amount. So if you're ever missing something that you really wish you had, you just have to look and say, what did they give me? And if they gave you something, plug in. There's probably something that will be missing, like a variable, that you then have to go ahead and solve for. So in this one, I'm going to take that clue, I'm going to plug it in my original equation and say A, 1505, is equal to P, what I began with, 500. So this account has grown, some time has passed. Specifically, how much time? Is that 10 years? You guys know what to do if you have something missing in an E. Yeah. We can divide both sides by 500. I'm going to do this one a little bit more step by step, because I might have lost a few of you guys trying to do it all at once. ln of both sides gets rid of the E. We end up with 10R. Hey guys, real careful. When you plug this in your calculator, which of these are inside the ln? You know what I mean, right? Which of them are inside the ln? Top, bottom, both? Both. Just make sure. If you end the parenthesis too early, it's the answer, right? Just be careful. Both need to be inside the ln. And then I can go ahead and divide by 10. Sorry. So then, Joe, that would get you your R as a decimal, so you would just need to go ahead and change that into a percent by moving it 2 places. I'll write it a little bit nicer. That was really messy. I apologize. and then for the time to double. Once I have my R, it's going to be like a decimal, but we'll put it here as a percent. My guys that already went ahead and graded it, what did the R end up being, just for sake of us using it? Alana, do you have it? 11.01? Oh, 11.0%. Thanks, and thanks, Jason, for chiming in. So we have our 11%. At this point, we could go ahead and come back to our formula and say, hey, we can update this. Now we know it's A equals 500 e to the 0.11. And so now when it says time to double, Jordan, we can use your trick. If we knew it was 500, what's the amount going to be now that it's doubled? It's going to be 1,000, yeah. Or we could use my trick and we could say, well, whatever it is, yeah, I know that it's now double what it was before. So either way you go, both ways work, because both ways, whether it's 500 and 1,000 divide or 2p and p and divide, you're going to end up with 2 equals e to the, where I can take ln of both sides and divide to get t. Okay. Any other evens or odds? There were some really tricky ones, are you sure? Okay. Then you guys had your, oh, Priscilla, go ahead. Yeah. That's actually really helpful, Priscilla. Thank you for that, because I wanted to get to some of the word ones at the end. Because I already had you guys highlight that first table, right? That first table saying like, hey, there are there's a test problem like the table. I would love to show you guys another, hey, there's a test problem like. Now, good thing is there's not a test problem like number 55. Because 55 is confusing, because it's very specific as far as talking about pH levels of liquid. Like, that's rough. And we would have no clue what to do except, hold on, look back, look back, look back. We would have, yeah, I know it's so hard. We would have no clue what to do if they hadn't given us the, hey, P.S., you're not in chem right now, so let's give you what the formula is. So you don't need to have this memorized. For tomorrow, any of the things having to do with the sound or having to do with the pH where they gave you a special formula, you don't have to memorize that. PERT. PERT is the one I want you to know for tomorrow, like memorized. Does that make sense? Everything else, if a formula comes, use it. If a formula comes, use it. I'll try to, this isn't one like the test, but let me quickly show what to do. The formula is pH equals negative log of, and the H, if you guys keep looking, is the hydrogen ion concentration. So negative log of H, and so if you look up here, they tell you apple juice has this pH of. It's just kind of matching variables. So if I was to make little formulas out of this, I can say, okay, the big formula is pH equals negative log of the concentration. Okay, I have two different things. I have apple juice that has a pH of 2.9. And then I have drinking water that has a pH of 8.0. So I'm just plugging into the pH spot because that's what they gave me. I'm like, all right, fine. Negative log of. And then it says the hydrogen ion concentration, aka the little H plus, is how many times the concentration of drinking water. If I were you, they're asking us to compare their hydrogen ion concentrations. They're this little piece. We'll have to get that alone. So to get that alone, I would go ahead and multiply both sides by a negative. Hold on, let me check the directions real fast. The acidity model. Okay. Logarithms are tricky. Oh, it's going to be fine, sorry. In my brain, I was worried about the domain restrictions of logs, but it's not a big deal. I just needed to go. Multiply both sides by a negative. Go ahead and do 10 to the power of both sides. 10 to the power of, good. The hydrogen ion concentration of apple juice. This guy could do the exact same thing. Multiply both sides by a negative. 10 to the power of. and I get the hydrogen ion concentration of this guy is 10 to the negative 8. And they're asking how many times is this one to that one? Well, I could say this guy. I was about to do my carrot, sorry. Apple juice is how many times. I like to use N for number of times. I use it in finance, or it is in finance. You can use X if you want, but this is how many times this guy. Just had to make like a little baby equation, then you can divide and solve. Does that make sense? But this is a really, like, all the chem formulas, once you get into them, they're kind of confusing if you're not in chem as far as what's going on. Like physics with this decibel thing. So, ready? If I were you, I would highlight. Let me go find a good problem for tomorrow. Sound good? A good problem for tomorrow. Help me out. After the table, guys, which was like in the 20s. Starting around number 29, let me know what problems you had. Let's go ahead and start listing them off. Did you guys have 29? No, keep going. What was the next one? Okay, what else? Okay, what else? Give me a sec. 45? No. What else? No. What else? Okay. Okay. 166. Out of your homework problems, I would say the best one to highlight as far as what tomorrow would look like would be 31. Does that sound good? So how many types of problems did I have you highlight in section 3.5? One from the finance table and one from words. Sound good? Okay. So that's specifically. I just said the table. Like knowing, and I mean literally, like knowing what to do with initial, knowing what to do with time with double, knowing what to do amount after, like literally the table. But I just won't tell you which one. Yeah. Because I'm not giving you the exact same problems, right? But it's a pretty good hint, similar. Okay, with that, let's go ahead and remind ourselves of all of chapter 3. Because 3.5, did it get super specific as far as logs, logarithms, and exponentials get used in stuff in life? That's the point. Okay, but the whole chapter 3 wasn't like that, was it? Right? Let's look at the review really fast. And some of you are like, I haven't gotten to start it yet. Well, maybe you can start it right now because oh my goodness, it's taking forever. Okay, because with the review, could it be something as simple as, do you know how to use your calculator with logarithms and exponentials? Yes. P.S. Have your calculator for the test tomorrow. Have your calculator. Okay? Because it could be something as simple as, do you know how to use the caret button? Do you know how to use the logarithm button? Do you know how to use the ln button? It could be something as simple as that. There could be a question having to do with, hey, transformations where you have to realize, oh, adding outside is what kind of transformation, guys? Good, vertical shift, good. Adding inside, horizontal shift. Yeah, I'm not going to make you guys stress about like stretching that gets really complicated with logs and exponentials, but could there be a negative? Yeah. Yeah, so then flip, Joe's helping us out in the back with reflections. Good. That was all from section 3.1-ish. So we went to the basics of, hey, who's an exponential guy and what's his graph look like? If you guys are in your notes, I'm kind of going section by section. You could kind of highlight some things I say. So section 3.1. Do you know how to plug in? Do you know how to use the one-to-one property? Do you know how to talk about transformations of graphs? General ones. Hey, one-to-one property gets tricky right about here. Can you guys tell which of these that you might think or others in your class might think are the trickiest in this little section with the one-to-one property? What are we trying to do? Get the what to match. So what's tricky about 17 and 18? Why is it harder than normal? No big deal. 3 squared. Ugh. I would highlight number 17 if I were you. How do we change a fraction to be a whole number so that we can compare? Matthew, I know how your brain works. Hold on. It's going to be different than everyone else. How would you guys rather see it? Would you rather it be a 3 or a 1/3? Yeah. So 3 squared, easy. How do I make 1/3 into a 3 to the power of? You might want to write down, what is 1/3 as 3 to the power of? 1/3 is 3 to the power of negative. You need a negative number. So what if I was to do something completely unrelated, like 1/16? What base do you think you might want to get that one into? But what power would it be of 4? -2. So we can make any nasty fraction look like a nice little number as long as we make the powers negative. That might be a good note to make. That could be tricky for tomorrow. Every now and then, something comes up where you have to like factor a quadratic. Like say there was a squared in there, you might have to do a little like move it all to one side. The one-to-one property says as soon as the bases match, ignore the bases, set equal to the powers. You guys actually really one-to-one property when we were going through homework at least. But after we talked about exponentially things in section 3.1, what started coming in section 3.2? Some of you guys might want to think about how to transform from logarithms to exponentials, but I was really trying to have you guys in your brains master the idea behind it, so it wasn't just memorization. So for example, even though you could memorize how to go backwards or forwards from exponential form to logarithmic form, and we wrote it in our notes, so some of you might want to highlight that and memorize it. Didn't we learn how to move around stuff? How could we get rid of the base 2 if we didn't want it? Yeah, we could do log base 2. We could rewrite log base 2 of that one and log base 2 of that one. What happens if you take a log base of a base to a power? The power drops down, and as long as they match, it disappears, right? So actually, could you memorize how to go from here to here and back? You could, or you could understand the math of to undo an exponential, just take a log base. Or to undo a log base, what do? Yeah, I hear it. It's just really quiet. A 2 to the power of both sides. And what happens when I do 2 to the power of log base 2? It just goes away. Good. So remember, a logarithm is asking what power of. So we could actually, a way of solving this one, if you ever see a log base 2 of 8, couldn't we rewrite that and say, oh, hey, that's log base 2 of 2 cubed? That's a way of solving logarithms by hand. And that as long as you can get the bases to match, the logarithm will equal what's left over. That's called the, in a sense, the inverse property. The inverse property. Now, I'm trying to show you that you don't necessarily, as long as you understand how to work with logarithms and exponentials, you might not need to memorize everything, but hold on. Is there stuff that we should probably memorize? Yes. One of them shows up in section, I don't think it's actually 3.2, because 3.2 talks about the basics of the graphs. So if I were you guys, I would highlight exponential and logarithmic graphs. There's not going to be a long answer. Maybe there should be, but there's not going to be a long answer. Since you guys have your graphing calculators, I'm not going to test you on whether you can graph the functions by hand, because it would be too easy just to cheat and to pretend. But even though I'm not telling you to memorize the graphs, it's still good to know what an exponential and a logarithmic look like, and things like vertical and horizontal asymptotes. So you might want to highlight about the graphs of in 3.1 and in 3.2, exponential and logarithmic, the shape of it, and things like the domain problem of logarithms. Because if you were to be given something like number 54, if I was to ask you domain, that's pretty important in math, what would its domain be? Has anybody gotten there in their notes? What's the domain problem for logarithms? This needs to be greater than 0. So if this is greater than 0, x has to be greater than, I would add the 3. And so if I were to ask you where the vertical asymptote is, if x has to be greater than 3, then what do you think is blocking it? So where is the vertical asymptote? At 3. And that's in the notes. We kind of talked about vertical asymptote. It's when the inside of the logarithm is 0. So if you find a domain, the boundary of the domain is the vertical asymptote. That's a little trick, a little hint. So I would say that you should study the domain problem of logarithms as far as memorizing. You should study in section 3.3 the properties of logarithms, the product, the power, and the quotient properties, expanding and condensing, making sure you have those ones down. I would say that you should memorize, I don't know about memorize, but at least study the one-to-one and inverse properties. Those are pretty important. But for logarithms, didn't you have something else that we kind of needed to memorize called the change of base formula? Now, just a few of you are like, but I have that cool button in my calculator. Well, I might phrase a question on the test where that cool button on the calculator wouldn't really help. So, long story short, also please look over the change of base formula for your own benefit. Not this proof, don't worry about that, but the change of base formula. I think we actually covered it in 3.2, but that's a good one to memorize. So what we've talked about so far, domain of logarithms, we've talked about the log properties, we talked about the change of base formula. As far as memorizing, though, the only other real thing to memorize, I think, because this section was just playing with equations, and for that you guys need more practice, or maybe to go back to other problems that we did do and then rework them without seeing the solution and seeing if you can actually make it match. The only other thing to actually memorize, I would say, is PERT. The only thing as far as memorizing, I would say, is PERT. Unless you want to do things like memorize the clues in the table to be ready for if something like time to double shows up, you know what to do. But otherwise, I think the rest of getting ready for tomorrow is practice. And so what have I given you to that end? I've given you the chapter review. Okay, it's going to have basics. It's going to get harder, a little bit harder as you go. But the long story short is, do you have the foundation of exponential and logs to be able to face equations and to face eventual word problems? But I was very specific on which ones to study for tomorrow. Kiddos. Real quick, walk through logistics. When you walk in the door tomorrow, what do you do? First thing first. Phone, make sure sound is off. Before you even go to your desk, how could you just get everything done out of the way so you can settle in, breathe? You can turn in your notes and homework spiral. Pause. Look at your notes. Is the table of contents totally up to date? I had to take points off of some of you last time because you didn't write down the last section with the page number. Make sure your table of contents 3.1 all the way to 3.5. Okay? Titles, page numbers, etc. Homework spiral. Make sure every single one is attempted. We went over questions in class, so there shouldn't be empty problems still with question marks. We should have answered them. Make sure that you've shown your grading in a colored pen. My ones that grade in pencil, I can't tell your grading. You have black pens, you're not obeying directions. Make sure you've graded in colored pens, and if you got absolutely everything randomly on a homework right, show me that. Show me that you got each one right. Except the test review. That one's just kind of like a try it, check it out. Okay? I think they're the only big things as far as logistics and things that can take off points. When you get back to your desk, you're allowed to have your calculator, and you have to have a cover sheet. You can have two pieces if you want, so one can be kind of like flipped and covering. Your calculator can cover multiple choice answers tomorrow, which kind of frees you up as far as space. But you do need to be covering your test, and you can have scratch paper out and open. Are there any questions as far as logistics for tomorrow? Okay. Any questions as I was talking or reviewing where you're like, oh, I really don't like that kind? Okay, then can I end class with a quick example? Is that cool? Just kind of random off the top of my head, but thinking of the test for tomorrow. What if I was to give you a link? What do you think the directions would be? Solve for t. Cool. What would you guys do? Divide by what? Good. Gross. That's okay. It can be gross. Now what? Log base 2? Sure. Or you could do ln both sides and bring down the power. But yeah, either one. If it's a long answer, I'll take either one. And if it's a multiple choice, can you make yours match, maybe with the change of base formula? Or maybe it'll be a decimal and you could just plug in. And what happens now? Yeah, the log base 2 and the 2 to the power cancels. Are you allowed to, on a long answer, leave it messy? Yeah, I don't mind. Add 1, sure. I don't like it, but as long as you don't combine it, it's okay. And then divide by 3. You can either divide the whole thing by 3, or you could multiply by 1/3. What I want to show you is you don't need to stress on long answers making it pretty. If you want to get me a decimal, that's great. I'll check it with my decimal. But I'm going to be checking step by step, and as long as all your steps measure out, all of them are correct, I'll give you full points. Does that sound good? Yeah. Okay. Guys, practice with the review. If you have questions, I'll be here lunchtime, period 7, or after school. I'll say until 4, until 3:45 or 4. Yeah. Come on in if you need it. Did you guys get the review done? Hopefully. I have whiteboards. If you want to come in and say, I'm struggling on, I'll give you practice problems like the test.